Hello everyone, welcome to EnviroPioneers. Like vegetation, as we discussed in the last video, the spectral signature of water also provides valuable information about it, and by understanding its spectral response across different wavelengths, it can be utilized in the remote sensing of surface water for its biophysical characteristics. Water exists in various states on Earth. It can be fresh water, salt water, water vapor, rain, snow, and ice. For different surface water bodies, in situ data collection is possible for particular locations. And here are some of the parameters, for example, precipitation, water depth, temperature, salinity, velocity, volume. For this, we have to actually go on the field, and then using the different instrument, we can collect the data. And then for water quality, we have to collect the water samples from the field, and then it can be brought to the laboratory for various chemical assessment. In situ data collection for a specific location, that is feasible. But if we have to gather the information on a larger scale, for example, here we have some of the example that water surface area, water constituents, and then water depth, water surface temperature, snow surface area, snow water equivalent, ice surface area, ice water equivalent, cloud cover, or precipitation. So if we want the information on the larger scale, in situ data collection, it is little difficult. So in that case, remote sensing, it is very useful and helpful in gathering the information on the larger scale. Remote sensing of water is also referred as the aquatic remote sensing, where the optical information about the water bodies are collected from variety of different platforms. It can be satellite, airborne, drone, or the ships. Now, here in this image, we can see the remote sensing reflectance against the wavelength. And we have three graphs. One is of the pure deep water. The second is algae laden water. And then brown one is showing the sediment laden water. Now we can see that the pure deep water is having the spectral response where the reflectance it decreases after 550 nanometer. But if the water bodies are having the impurities, either it is of the phytoplanktons or if it is sediment, now we can see that spectral response it changes. Now we will understand the interaction of the electromagnetic radiation in each case one by one in detail. The total radiance recorded by any remote sensing system over water is the function of electromagnetic energy received from four different sources. One is from the atmosphere. So this is referred as LP, that is the atmospheric path radiance. Then second source is from the surface, means the radiation which strike on the surface and it gets reflected. So it is referred as the free surface layer reflectance or the boundary reflectance. Then the third source is the portion of the radiation which actually penetrate the water body and it interacts the water components, and without coming in contact with the bottom, it again propagates back through the medium and exit the water bodies into the atmosphere. So this is referred as the LV, that is the subsurface volumetric reflectance. And then last one is the portion which actually reaches to the bottom, and then after interacting with the bottom it again propagate back towards the atmosphere and then exit from here, and this is referred as the LB, that is the bottom reflectance. So the total radiance which is observed from a surface water body is actually the combination of these four. So for remote sensing of water, the data is corrected for removing the atmospheric path radiance, because this portion it actually never comes into the contact with the water. So this portion is removed, and then these three, that is the free surface layer reflectance, subsurface volumetric reflectance and the bottom reflectance, are utilized for studying different biophysical characteristics of the water bodies. Subsurface volumetric reflectance, it gives information about this part. So It provides us information whether the water bodies are having any type of impurities or not, because depending upon the impurities, the reflectance will vary, and the bottom reflectance, it gives the information about the bed of the surface water bodies. As the sensor records the information about the atmospheric path radiance, surface reflection, subsurface reflection, and the bottom reflection, scientists, they utilize different approach for differentiating the information coming from the subsurface and the bottom, because the subsurface volumetric reflectance, it provides us information about the type of impurities which are present in water, while the bottom reflectance give us idea about the type of composition of the bedrock. Here we can see that there are two type of bedrock present at the bottom. So depending upon the composition of these bedrock, the reflectance, it may vary. So this bottom reflectance is utilized to understand about the characteristics of the bottom or characteristics of the bedrock which is present beneath the water bodies. This image, it shows the absorption and scattering attenuation in pure water. The data collected for absorption and scattering attenuation coefficient from various studies were compiled to understand how different wavelength interacts with the water molecules. So here we can see two lines, one is for the absorption and second is for the scattering. The absorption, it dominates in the ultraviolet region less than 400 nanometer, and after yellow portion, that is after 580 nanometer. So we can see that all the wavelength which is less than 400 nanometer and more than 580 nanometer, that are strongly absorbed by the water molecules. When it comes to scattering, it is dominant in the shorter wavelength and it decreases as the wavelength increase, and it is nearly negligible in the near infrared. Considering both absorption and scattering, we can see that this is the only wavelength range where we are having the minimum amount of absorption and considerable amount of scattering, because for the wavelength which are lesser than 400 nanometer, we are having the considerable amount of absorption, and after 500 nanometer, again the absorption, it increases. So rest of the wavelengths are absorbed by the pure water molecules, and this is the only wavelength range where we are having the minimum absorption, and the scattering of the blue color or the blue wavelength in the water, it makes the water bodies visible to us in blue color. And if we notice here, the NIR is completely absorbed with negligible scattering here. As we saw in the last diagram, the pure water molecules, they absorb all the wavelength falling in the NIR and MIR. This particular wavelength range, that is 740 to 2500 nanometer, is considered the best for discriminating the land from the pure water, and is also very important in monitoring the surface extent of the water bodies, because in NIR band, these water bodies appear very dark, even black in color. Here we have two spectral signatures, one is for the vegetation and second is for the water, and we can see the difference in the NIR range. So in NIR, the vegetation, it reflects in much higher quantity, while in water this NIR is completely absorbed. And this is the reason that when we select the NIR band, the water bodies, they appear very darker in color, because this NIR is completely absorbed and is visible in this image as black in color, while the other surfaces where we have the vegetation or the bare soil, there we have the significant amount of reflection in the NIR or MIR, and those places appear either gray in color or white in color depending upon the amount of the reflection. Here we have the false color composite made by the NIR red and the green band of the satellite data, and we can see the all the vegetation, these are red in color because of the high reflectance in NIR, while the water bodies are darker in color, and we can clearly see the spatial extent of the water bodies and demarcate the water and the land boundary in each of the images. Surface water bodies are dynamic in nature as they shrink, expand, or change their appearance or the course of flow with time, which may be because of the natural or the human induced factor. And in this case, remote sensing technology, it offers very effective method to observe the surface water dynamics. Here in this part, we can see the temporal changes in the surface area of a lake, which has been derived using the Landsat imagery. So here October 1996 to October 2018, we can see the surface area has decreased drastically. Here in this image, we can see different geomorphological structures which are formed because of the change in the river pathway. The reflectance from the water bodies can also be helpful in identifying the depth variation, because if the water body is shallow, there will be reflectance from the bottom and it will contribute to some amount of reflection in the red and the NIR band. But if it is a deeper water body, then the bottom reflection is very negligible. Here in the false color composite image, we can see the variation in the color of the water bodies. Here we are having cyan color, while here we are having the very dark blue color. So this color change, it may be either because of the impurities, or second possibility is that this water body may be shallow in comparison to this. Because in case of the shallow water bodies, the bottom sediments may contribute in some amount of the reflection in the red or the NIR range. अभी तक जो हमने पढ़ा दैट वाज स्पेक्ट्रल रिस्पॉन्स ऑफ प्योर वाटर, बट जो हमारी नेचुरल वाटर बॉडीज हैं दे कंटेन सम अमाउंट ऑफ इम्प्योरिटीज. दीज इम्प्योरिटीज मे बी आइदर ऑर्गेनिक और इनऑर्गेनिक in nature. Now we are going to understand the spectral response of water as the function of organic and the inorganic constituent. Organic constituent is mainly because of the phytoplankton which contain the chlorophyll pigments, and the inorganic components are mainly because of the suspended minerals. And the subsurface volumetric radiance, it is the function of concentration of pure water plus the inorganic suspended mineral plus organic chlorophyll A and dissolved organic matter. Here in this image, we can see two spectral graph. This is of the clear lake water which is having the 10 milligram per liter suspended solid, while this is of the turbid water which is having 99 milligram per liter suspended solid. And we can see that because of the increase in the turbidity, the reflectance, it increases in all the wavelength range starting from here and also in the NIR range. Inorganic impurities or the suspended minerals may enter into the surface water bodies from various sources like the upland agriculture, cropland erosion, or weathering of the mountainous terrain, or shoreline erosion, or volcanic eruptions. And these particles may range from the fine clay particles or silt or fine grained sand or coarse and grained or gravels. And the suspended matter concentration is high in inland or the near shore water bodies in comparison to the deep ocean. So suspended mineral impurities are negligible in the deep ocean, but it may play a major role in the inland and the near shore water bodies. Here we have two images where we can see the impurities getting added into the river from the surrounding. Remote sensing cannot directly measure the concentration of impurities in the river or the surface water bodies, but the in-situ data collection along with the reflectance, it can play a major role in long-term monitoring of the surface water bodies. So, in-situ data collection for the turbidity can be done using the Secchi disk or the nephrometer. Here we have the example of the Secchi disk. Secchi disk is a circular disk which is generally inserted from the surface, and the depth up to which this disk can be seen, it is inversely correlated with the turbidity. And the nephrometer, it directly gives the concentration of the turbidity in NTU. In this part we can see that more clear is the water, more will be the light penetration, और हम ज़्यादा depth तक इस Secchi disk को clearly देख सकते हैं. And in turbid lake where we are having the impurities, light penetration will be less, and because of that बहुत ही कम डेप्थ पे ये Secchi disk हमको दिखना बंद हो जाएगी. जिस डेप्थ तक हम इस Secchi disk को देख पा रहे हैं, that is inversely proportional to the turbidity. यहाँ पे हमारे पास अगेन टू एग्जांपल्स हैं. यहाँ पे हमारे पास कम algal count है and more light penetration, and here we are having the high algal count with less light penetration. तो जो डेप्थ, जिस डेप्थ तक हम ये सेची डिस्क को देख पाएंगे, that is more in this case and less in this particular one. Turbidity value, either with the help of the Secchi disk or the nephelometer, and the reflectance value using the spectroradiometer can be collected, and the plot which is made for different wavelength range and the reflectance for different concentration. It is helpful for long-term monitoring of the surface water bodies. Here we have the two reflectance graph. One is for the clay soil and one is for the silty soil for various concentration of the turbidity and the reflectance values which is observed using the in-situ spectroradiometer for different wavelength range. So here we are having the 400 to 900 nanometer in both the cases. In both the images, on the y-axis we are having the percent reflectance and on the x-axis we are having the wavelength. So we can see in both the cases that the reflectance, it increases because of the turbidity. So here we are having the decrease in the reflectance after 550 nanometer in the case of the clear water, but because of the impurities, the reflectance across all the wavelength range starting from the blue to NIR, all the wavelength range, the reflectance has increased. And as the concentration increases, so here we are having in milligram per liter. So this is for 50, this is 100, 150, 200, 250, and this is the range from 300 to 1000 milligram per liter. So we can see that reflectance in all the wavelength range has increased, and especially after the NIR range, because in pure water the NIR is completely absorbed, but in case of the impurities the reflectance in the NIR is also increased. And in case of the silty soil, we are having the again same pattern, the reflectance, it is increasing. In both the cases, the reflectance peak, it is shifting towards the longer wavelength as the concentration of the sediment is increasing. But if we compare in these two images, the reflectance in case of the silty soil is higher in comparison to the clay soil. So यहाँ पे अगर आप notice करो, on the y-axis it is 0 to 5 only, but on the this part in the silty soil, here we are having the range 0 to 14. So the silty soil is having more reflection in comparison to the clay soil, because जो silty soil है, these are mainly lighter in color, and because of that it is having more reflection, while the clay soil, these are mainly darker in color, and because of that इसका जो reflection है, that will be lesser in comparison to the silty soil. But overall, if the impurities are getting added, the reflection will increase in comparison to the clear water. Next is the organic impurities, that is mainly because of the phytoplankton which contain the chlorophyll. So here we have two examples, the water which is having the algal bloom. In this image we are having the two spectral signature, one is of the clear water and second is of the algae laden water. So in clear water we can see we are having the higher reflectance in the blue wavelength range, but in the algae laden water the blue wavelength range and the red wavelength range is absorbed, while we are having the higher reflectance in the green wavelength portion and also in the NIR portion. So this change in the spectral graph, it is mainly because of the chlorophyll pigment. So here again we can see these are the 2 points where we are having the chlorophyll absorption. This peak is mainly because the green portion is not absorbed by the chlorophyll and NIR reflectance by the vegetation. In this image, we are having the reflectance percent against the wavelength for different concentration of chlorophyll, and we can see that as the concentration of the chlorophyll it increases, there is increase in the reflectance in the green portion, that is 500 to 600 nanometer, and then also increase in the reflectance in the NIR portion, that is after 700. So because of the chlorophyll pigment, there is change in the spectral response of the water bodies. This image, it shows the schematic diagram of the depth categories. So here we have the optical remote sensing. It can be utilized for the shallow water depth, means depth up to 50 meter. Sonar, it can be utilized for medium water depth 50 to 500 meter, and for the deep water category which is having more than 500-meter depth, there the satellite gravimetry can be utilized. So the optical remote sensing, it is mainly useful for the inland water or for the coastal or the shelf area, and for the deeper ocean the sonar and the satellite gravimetry method is highly preferred. Apart from the inland water bodies or the freshwater sources, the remote sensing is also utilized in number of applications in the ocean. You can go through this review paper, that is the Ocean Remote Sensing Techniques and Application, where the authors, they have compiled the application of the remote sensing in different ocean phenomena like the fishery, ocean underwater, oil spill, chlorophyll, ocean color, surface salinity, sea surface temperature, iceberg, and sea ice. So we can see here that for monitoring the fishing fleets or fish stocks, or for bathymetric mapping port management, oil drilling, fishing, or for ocean pollution, fisheries, food security. So for number of applications, this remote sensing is utilized, and depending upon the application, there are number of sensors from which the data can be collected for using it for that particular application. These are some of the references from where the content of this video has been taken. The first one is the introduction of aquatic remote sensing, in which the basic has been given. The second is of the review paper, where the authors have compiled about the application of the remote sensing in ocean. And third is the remote sensing of the environment. In this book, there is one chapter, remote sensing of water, from where from there this concept or the images have been taken. Thank you for your support. We will meet soon in the next video. Thank you.